Hey, what's up, 7th grade? This is lesson 86, where we talk about number families, or really just ways that we can group numbers together by what kind they are. Just like most of the people in your family are going to look similar, or they have similar characteristics, the different numbers and the different groups, or the different number families, also going to have similar characteristics. So the first set of numbers is what we call the counting numbers, or the natural numbers. This book calls them counting numbers. Every other book I've used, they calls them natural numbers. But either one of those is absolutely fine. And we use this cool symbol right here, this N, which has like a double line across it there, to represent that, or abbreviated way to say that. But the counting numbers are just numbers that you would count with. So like 1, 2, 3, 4, etc. And we put those 3 dots to just symbolize that it just keeps going on, following that same pattern. So that's the smallest, the most simple set, called the counting number. Starts at 1 and goes up. The next set is the whole numbers, and we use a cool W like this. I couldn't find a picture of one, so I had to draw it. Sorry, my drawing's not as good as these. But the whole numbers is very similar to the counting numbers, but it just adds one more number, because they realized, or someone realized, the counting numbers wasn't complete. If I wanted to count something, count how many cows I have, but all the cows are gone, then I have to be able to say that there's 0. So counting number starts at 0, and then goes 1, 2, 3, 4, etc. Keeps going up like that. Then that group wasn't big enough, because they started borrowing things. And they realized, hey, I need to owe you. I need to have a negative amount of cows, or whatever it may be. So the integers has 0, 1, 2, 3, 4, etc. But it also has the negative 1, negative 2, negative 3, negative 4. So it actually goes for infinite in both directions. Okay, now before we keep going, notice that every number of the counting numbers, the natural numbers, is also a member of the whole numbers. And every member of the whole numbers and the counting numbers is also a member of, or part of, the integers. Oh, and for integers we use a z. Don't ask why, that's just the way we do. Okay, and then the next ones are rational numbers. So rational numbers are numbers that can be written in a ratio. That's how I remember it, ratio numbers. So think about numbers that you can write as a fraction. So it also includes all of these numbers that we've already talked about. For instance, 2 is the same thing as 2 over 1, so I can write it as a ratio. But it also includes numbers like 1/2 that were not included with the integers or before. And it includes numbers like 1/3, or it includes numbers like 0.6666666. Okay, just 6 repeating, all right? 6 repeating, yeah, there we go. Numbers like 2 and 2/7, or different things like that. So any number you can write as a ratio goes into that rational number category. Now, this book doesn't talk about it, but I'll go ahead and just mention it here. There's also a category that we call not rational. Okay, the not rational ones would be numbers like pi, or the square root of 2, or the square root of 6, things like that. So we won't really be working with those, but I thought it might be good for you to at least know about them. And then the last set, and the biggest set, well, I say the last set, there's actually more after this, but you'll learn about that later on in algebra class. The last set we're going to be working with in this class is going to be the set of real numbers. And the real numbers just includes all of these up here, as well as the irrational numbers. So generally we refer to the real number set, that's kind of one we go to in general, but we'll specify sometimes these other ones. So just as a visual aid, the smallest one in yellow is the natural numbers. Those are just 1, 2, 3, 4. Notice all of the yellow ones are inside this green one, the whole numbers, because the yellow ones are inside the green. All of the yellow are included inside the green. Likewise, all the whole numbers are included inside the blue, inside the integers. All the integers are included inside the red, and all the red are included inside the black. So let's see if we can do a couple examples here. Example 1.1, graph the integers that are less than 4. So first off, let's just make sure we realize it says integers that are less than 4. So on number line, here is 4, 3, 2, 1, 0, -1, -2, etc. If I were to graph all of these, less than 4, be 3, be 2, it'd be 1, it'd be 0, it'd be 1, be 2, etc., going on further to the left. Okay. Notice we would not include the 4 because it said less than 4, and it's integer, so we just include the 3, the 2, the 1. We wouldn't include any numbers in between those. Now, if we had one that looked a little bit differently, like this one, it says graph the real numbers that are at least 4. Well, that would look a little bit different. Now notice it says real numbers and at least. So here's 4, so I would include the 4, and I'd actually include all of those. Sorry, let me use a different color. I'd include the 4, and I'd include all of the numbers out this way that are bigger than 4, because all of those numbers out there are at least 4. Now this is example 2. It says answer true or false. All whole numbers are integers, so let's just kind of go up here. Are all whole numbers, the green ones, are they integers? Are all of the green inside the blue? Well, the answer is yes, so then I would say true. Let's look at the next one here. B, all rational numbers are integers. All rationals are all of the red numbers, the blue numbers. Well, are some of the rational numbers blue numbers? Yes, they are, but are all of these in there? No, that is not the case, because say 1/2 is a rational number, but it is not an integer. So then this one I would say false. Your homework is on page 594. You're going to do the practice set, all the 86s, all the 85s, and 9 more of your choice.